calculus lesson on derivatives of trigonometric functions. Okay guys, there's a warm-up over here. We'll be doing that in class, so you should kind of look at it, but don't bother at this point. I'd rather have you guys do it together. And if I'm not mistaken, this space might be a little bit tight over here, so you may want to do that on the back side. Alright guys, so start taking notes. Alright, we're doing 3.1 derivatives of polynomials and exponential functions, and the first thing is the ddx, right, of this expression, the monomial. The rule basically says is that whatever the exponent that you see here, bring that out to the front. We have that over here, and subtract that by 1. That's it. So as an example, we got 3x squared, but we are only working on the monomial portion. Forget the coefficient. And then what you do is you bring the 2 to the front right there, and you subtract 1. So that'll be x to the first, and you see that right there, right? And 3 times 2 afterwards is 6x. Just remember that, guys. Let's think about what the implication is. So this right here is telling you the graph looks something like that, which is like quadratic, right? And the slope all along as you go along, its equation is 6x. So when you have this, 6x is more like this. So when you're here, it's like you have very negative value slope here. Yep, it's very negative. This is 0 here, isn't it? So yep, intersects at x intercept. And very positive. Yes, very positive. Yeah, so that's basically it. So yeah. So basically this is telling you what we've been seeing before, which is that the relationship between the derivative and the original function did differ by degree of 1, right? So this is the, oopsie. No. There you go. That's the f right there, and this is the f prime. Okay. Now let's think about this one. What is the derivative of a constant? Well, what is the slope of a constant? Right? So when you have a constant like this, y equal to c, what's my slope? It's 0 everywhere, isn't it? Yep, that's what it is. And this basically, constant multiplication rule basically tells you what I just did over here. So I suppose I should have done that right after this. I was too eager. Sorry about that. And then sum and difference rule basically says that what I didn't write down over here is that we are operating under the assumption that f of x and g of x are differentiable. Right? We'll talk about what that means later on. Right? Well, you know what it is, right? It is continuous, and the limit from the left and the right must be the same. Right? Anyways. So we're operating on the assumption that f and g are differentiable, right? If that's the case, when you differentiate this, the differentiation of the sum is the sum of the individual differentiation. That's all it means, okay? And just something that you should know, the derivative of a natural exponent, e to the x, is simply e to the x. It's one of those shapes, this shape right here, guys. Yep. It's the the graph of the derivative, the functions, the slope, is exactly the same as the function. Isn't that funky? All right. So have you wondered why this must be true? Well, I don't want to sit here and spend the whole time talking about ins and outs of that. You're not responsible for this, but it's kind of fun to do. And here's the hint. You got to use the binomial expansion theorem using the limit definition of the derivative. So if you could do that on your own, that would be great, right? I'll show you the answer in a second, and there you go, right? Yeah, so given this, when you find the f derivative using the limit definition is f of x plus h minus f of x over h, right? As the h goes to 0, I just substituted in for the fact that function is x to the n, and x plus h to the n power, and I expanded this by what again, guys? That's right, binomial expansion theorem. That's what all this is, right? And then n choose 0 is 1, so that's x to the n, they cancel. But what do you notice about all this expression? They all contain the h, right? Which cross cancels with that. But the first one, once we cross cancels, we'll no longer have h expression. So what I should have had, that has to be grouped together like this, right? And every term over here, between here to here, still contains an h term. So using substitution rule, plug it in, they all disappear. Bingo, we're done. By the way, n choose 1, we all know is n. Yeah, that was it, guys. That was a derivative. It's kind of fun, right? So we have some examples over here. We're going to be doing these, right? So why don't you kind of pause the video and see if you could do this and apply the rules that you've learned so far, okay? And I'll just walk you through the answers. Okay, I'm going to go over it right now. So if you haven't done so already, you should pause the video. I'm going to assume that you've actually tried these. Now, here are the answers. Bring the 2 to the front, subtract. Then 2 is here. 2 minus 1 is 1. Bring 3 to the front, right there. Subtract 3 by 1, you get 2. Bring that to the front, you get negative 100. Subtract 1, you get negative 101. Now remember, guys, this e is a natural number. It's about 2.7, right? So you bring that to the front, and you subtract 1. We're done. So if I had 3.1 over here, guys, the answer would have been 3.1 x 3.1 minus 1, which would be 3.1 times x to the 2.1, right? So it doesn't always have to be a natural number or integer value. It could be any real number. Okay? Now, same thing over here, guys. We bring 2 to the front, and we're doing x to the 5th, which we know gives you 5x to the 4th. And when you multiply 2 and 5, you get 10x to the 4th. And we're applying the rule that we learned earlier, which is to treat this separately, right? So yeah, 3x squared, and then you get minus 6x to the 7th. And more the same, that will yield 12x cubed minus 18x plus 5, right? All right, guys. So we have differentiation over here. The key thing that you have to look out for is the first step, right here. This one, it's tricky if you don't write that as x to the power of a number. It's much easier that way, okay? E to the x, we know what to do with that. We did that already, didn't we? Yep, we already did, right? And then we have this. You have to recognize that's a constant, right? Once you do that, bring the negative 1/3 to the front, subtract 1, you get negative 4/3. E to the x derivative is e to the x. This one we already did. Derivative of the constant is a 0. Therefore, that's the answer. Okay. I do have an extra practice here for you. Here it is, right? That's the answer right there. In yours, it's kind of upside down. So there. So you guys asked for more practice. So here it is, right? All right. So this is a note. This S note, that's for you guys, right? Do me a huge favor. Pause the video, try this on your own if you can. If not, just let it roll. Okay? All right, guys. This is it. So when you're doing this, the first thing, I'm going to show you the answer in the back, but on this page, I'm just going to walk you through what you should do. Think about this, guys. We're looking for normal to the curve. You have to ask yourself, what the heck is normal, right? That is perpendicular to the tangent line. So that's first thing you have to understand. And it says equation of the line. Well, equation of the line is not basically, don't you need x naught, y naught, and a slope of some kind? So you get y minus y naught equal to m times x minus x naught. Yeah. So we have a x naught. We've got to find the y naught. So you find the y naught by putting y of x naught. So basically, it's a fancy way of saying plug this into this equation, And then when you do that, you will have x naught, y naught. That's step number 1. The step P, the pre-step, is that you have to read the question and examine what you should do. Step number 2. Well, what else do I need? I need slope, right? Find y prime, differentiating this equation that you're given to you, and which is equal to m. And the implication is that you could find that by understanding that the perpendicular slope and slope is -1, or simply that perpendicular slope is -1 over m. Putting it together, we're done. And the answer is this right here, guys. All right. The approach to this one is you read the question first, and it's asking for a tangent line is horizontal. Okay, hold on a second. If it's horizontal, my slope is, which is y prime, has to be equal to 0. Tangent line, horizontal, we're talking about this, this, and this right here. So I know that we got 3 answers, right? And then what that means is that the form that it takes, right, is y is equal to some value k, some number k. But how do you find that? Well, if we know the x value at which this happens, we can just plug in the values over here, right? Right. So the first step for you to do is, right, find values of x such that y prime is equal to 0. Then find the set x to plug in to the equation star to find the horizontal tangent line. Now, one of the things before we begin though, even if I did not show you the graph, you have to sort of think about this, guys. It's x to the 4th here, isn't it? Yeah, it's x to the 4th. And it's positive. So it's going to kind of look like this. Now, if this was perfectly symmetric, which this appears not to be the case, because it's not an even function, right? Well, technically, it could be symmetric without having to be even function, but it has to be shifted to the left to the right, but never mind that. But generally speaking, if it's 4th power, it could cross the x-axis up to 4 times, like this. 1, 2, 3, 4. If that's the case, there'll be 1, 2, 3, up to 3 answers. So we should have been able to sort of see that happening, right? Yeah. And in fact, there are 3 answers here. Here we go, guys. The answer is right here. Just like I said earlier, normal is a perpendicular to the tangent, and I want to know where that is, right? That point, I plug that into this equation. That's say, this right here is the x naught that I was telling you about, right? And then you plug it in, you get 1. So x naught, y naught is 1, 1. And I just drew a line over here and then estimated that first, right? In this case, I gave you the graph, right? And then you do the derivative to find the slope. And when you did that, take the derivative of this is what I got. And I plugged in x equal to 1, so that tells me what the slope is at that point, which is -1. But we're not done. We're not looking for a tangent slope. We're looking for a perpendicular slope. So we find the negative reciprocal. So -1 becomes +1. Check. Now that I have the point and a slope, we plug that into the point slope form, and that's my answer right there. As I said before, this follows the exact step that I talked about. First thing I notice that horizontal means slope is equal to 0, and then tangent line is a horizontal equation, which is y is equal to some number, right? That's the important point, is that I need to understand the form of my answers, which is down here. And I mentioned that when it's a 4th power, it might do, because it's positive, so it might look something like this, which gives me 1, 2, 3, up to 3. If it's possible that fourth looks like this, which minimum is 1. So you could expect anywhere from 1 through 3. Okay. So what happens? All right. So first thing we did is that I need the slope to be equal to 0. So I found the derivative of that, which I did here. I simplified it. I set that equal to 0 going down. Realize I have to factor it all the way. And then slope is equal to 0. I should have added the word when. Right? This equal to this. The slope is equal to 0. Right? Right. So now, because y, the horizontal slope is just a y value, so I say at x equal to 2, I'm going to plug that into this equation right here. And after some calculation, I get negative 8/3. Same thing with x to the 0, which gives you 0. And we could plainly see that. And x equal to 1, you end up with negative 5/12. And I enumerate all my answers and all together, so I don't have to search for it. Therefore, underline. If you want to box it, great. Put a smiley face, great. If you want to write QED afterwards, whatever you need to do, just indicate where your answer is. I'll greatly appreciate it. It makes my life slightly easier. Okay. All right, guys. We do have, after this, we do have a worksheet. See? All right. So here it is. We're going to work on this in the class together, as you know, with your group. So you just take a look at it, but don't do it because, you know, having that give and take is kind of important. Okay, guys. With this online learning, we need to replicate that collaborative learning as much as we can. So try to hold off. Okay. All right, guys. See you tomorrow morning.